Here in this problem, we are asked to differentiate. It's a natural log, so natural log prime is 1 over the function times the inner function prime, which is 1 over 2, the square root of the function times the inner function prime, which is 2t. I simplified t over t squared plus 1. Here it's a exponential function, and it's a function composition. It's not a pure exponential. So when I differentiate it, I have to use the formula, the differentiation rule as e to the function times the function prime. So when we differentiate the product, we have 2x times natural log plus x squared times natural log prime, which is 1 over x. That's why we simplify this into x. And we can factor out an x if we want to. Normally, I always like to factor, but we cannot take it any further, so that's fine. Factoring out an x is good. This is a typical function in which we do not have a differentiation rule. We have to apply natural log to both sides. So when I apply natural log to this side, natural log comes in front of times as a factor in front of natural log of sine x. And now implicit differentiation, 1 over y dy over dx plus, we differentiate natural log, copy the second function, plus copy the first, differentiate the second. Natural log prime is 1 over sine times sine prime, which is cosine. Cosine over sine is cotangent. I copied natural log, I copied this function, and I multiply both sides by y in the form of sine x raised to natural log x. Same thing here, we're differentiating. You know me already. I don't want, if it's a factor, I don't want to involve the factor, but if I have here plus 1, I cannot do that. But I took the factor out. Top function prime is 1 times the denominator minus the top times the denominator prime, which is 2t. So a negative 2t plus t squared will be negative t squared plus 9 with 9 in front. And I will factor out negative 1. And then I have t squared minus 9, which is t minus 3t plus 3 over t squared plus 9 squared. And this is the velocity function, assuming that this is the distance function. Next question was asking us to find v of 1. So all I did was I just plugged in 1 in the formula. 9 minus 1 is 8. 8 times 9 is 9 times 8. And divided by 100 squared, 1 plus 9 is 10. 10 squared is 100. Not 100 squared, but it's 10 squared. So I simplified by 4, and I got 18 over 25. And you can further simplify it or divide. 0.72 feet per second is velocity, feet per second. So vt of 0 gives us, so when I set this equal to 0, of course, I only get the numerator to be 0. A fraction is 0 when the numerator is 0, so t equals plus or minus 3. Of course, it's not acceptable. Only t equals 3 seconds because t must be greater than or equal to 0. So this is the domain of the function, 0 to infinity. This is the velocity, and this is the function. And we realize that when we study the sign of the velocity, everything here is positive, so we will only plug in into negative t squared plus 3. And if you plug in 0, you get positive. If you plug in above 3, you'll get negative. So obviously the derivative here is positive, and here is negative. So the particle moves in the positive direction, respectively, in the negative direction. And yes, I have to find f of 3 and put the number in here, and f of 0 and put the number here. And the reason I wrote 0 here is at infinity. And why did I write 0 there? Okay, yes, it is 0 actually. It is 0 because the numerator has degree 2, the denominator has degree 4. I'm here. The numerator has degree 1, the denominator has degree 2, so the horizontal asymptote will always be 0. That's all right. Okay, now total distance. So I have to determine the distance between 0 and 3, and the distance between 0 and 8. We're asked to stop at 8. So I'm adding the positive distance, which doesn't really need the absolute value, but to be consistent, f of 3 minus f of 0. But the distance between 3 and 6, actually, 6, it does need the absolute value because the direction of the particle is negative. So f of 6 minus f of 3, I plugged in all these numbers, and I found this is 1.5, and this is 1.2 minus 1.5, and 1.5 plus 0.3 is 1.8. So here is that figure showing that the particle moves in the positive direction and then in the negative direction. And we found the acceleration. I went back to this formula with minus in front, actually, and a negative 9. So I differentiate t squared minus 9 over this, minus 9, the top prime times the denominator minus the numerator times the denominator prime, and you know my habit, I always run out of room. So 2, the denominator prime, 2 times t squared plus 9 to the first power times the inner function prime, which is 2t. So negative 9 stays outside. I have 2t that is a common factor, and I have t squared plus 9 that is a common factor. From the first term, t squared plus 9 is left. This is out, so I distribute 2. I get negative 2t squared and positive 18. So this will become negative t squared plus 27. And then the 2t is outside. I simplify one factor of t squared plus 9. So then we have, I also factor negative 1. So I have now 18t squared minus 27. I'm asked to find a of 1, which is negative 0.468 feet per second. Acceleration is measured in feet per second squared. Okay, so here we're asked slowing down and speeding up. And I copied the table that I had for the velocity, same table. But I added the acceleration now and also the row for conclusion. And the acceleration is 0 at, I have it here. The acceleration is 0 at 0. And t squared minus 27 is 0, means t squared equals 27, and we take the square root, and we have 9 times 3. So that's why we got t equals plus or minus 3, the square root of 3. Of course, only the positive solution. And when I study the sign, I will not plug in anything in the denominator. It's always positive. Only in t squared minus 27. So it turns out that it was negative between 0 and 3, the square root of 3, by plugging in 3 if you want, and 6, and you get positive. You see that these two forces work against each other, is slowing down. They are working, helping one another, speeding up, and again, against each other, slowing down. Here we're given the distance formula. We're asked to find the velocity and where the velocity is where the distance is maximum. So we found the velocity, we set it equal to 0, and it's 2.5 seconds, and I plug in the distance formula to find the maximum height, which is 100 feet. I did not show a chart here because this is a quadratic function. It is a max, since I have to write a statement or study the sign. But here I didn't study the sign because it's a quadratic function. Since it is a quadratic with a negative leading coefficient, it will have a maximum. And find the velocity when the distance is 96, going up and coming down. We set the distance equal to 96. And we got, solving this quadratic equation, t equals 2, t equals 3. I plugged it in the velocity formula, which is this linear function. And I got 16 and negative 16, just the direction. This problem is asking us to determine the derivative of a concentration. And as I said, you know me, I will take the constants out like I did with 9 in a previous problem. I refuse to use that in the calculations. It can wait outside patiently. The top function prime is 1 times the denominator minus the top times the denominator prime. It turns out that these two go away, so this is the formula. Now we are told what if x is the concentration. So first I calculated a minus x, which is this, and it turns out to be this after I find the least common denominator and I multiply a by a kt plus 1. So I got a squared kt plus a minus a squared kt. These two go away, so that simplified form is this. And then I square that and multiply it by k. So k times this quantity squared will be k, a squared over the denominator squared, which happens to be exactly the derivative of the concentration. When t approaches infinity, obviously this limit of a squared kt over a kt plus 1 of the concentration formula. Use L'Hopital's rule because it's infinity over infinity. So it's a squared k over a squared over ak. So the answer is lowercase a in moles per liter. T approaches infinity. From this formula, that is 0, because the numerator doesn't even have t. When the denominator increases without bound, a number divided by a huge is 0. And the reaction stops. So these are a couple of questions from 3.11. Differentiate e to the x hyperbolic cosine x. The first function prime is e to the x times the second plus the first times the second prime. Cosine hyperbolic cosine prime is sine. Same thing here is e to u. E to a function is e to that function times the inner function prime. Hyperbolic tangent prime is hyperbolic squared of that argument times the inner function prime, which is 2. This is a quotient. I didn't have enough room here, so it's the last problem. So the top prime is hyperbolic cosine times the denominator minus the top times hyperbolic cosine 1 minus hyperbolic sine prime, which is negative hyperbolic cosine. I distributed in here and in here, and this is positive and this is positive. These two go away, and hyperbolic cosine plus hyperbolic cosine is 2 over that. Thank you.